So take a moment and using what you know about special right triangles, take a moment and draw a 30, 60, 90 triangle and label all the angles and sides with measures. And I also want you to draw a 45, 45, 90 triangle and label all the angles and sides with measures. And when you draw this, I'm not looking for you to get out your protractor and make these angles exact. I'm basically looking for you to do this. So let me show you what I mean here. So draw a triangle and label one of them as a right angle, one of them as the 30, and one of them as the 60. And same thing with your 45. And this is obviously not going to be drawn to scale. And then using what you know about special right triangles, throw some specific numbers in here that could possibly work. And if you need a moment to do that, go ahead and pause the video. All right, I'm assuming you had a chance to put some numbers in here. I'm just going to throw some numbers in. So let's say that across from my 30, let's say this side here was 4 units. And then I know that across from my 90, that's going to be doubled. So that's going to be 8. And across from my 60 is this one multiplied by the square root of 3. So this would be 4 root 3. And here, let's draw a couple more. So here's another triangle. And this is going to be another 30, 60, 90. And it looks like I just made this one a little bigger. So here, let's make this 5. And we'll say that this is 10. And this is going to be 5 root 3. And we'll do one more. See if I can make it even bigger. Once again, not drawn to scale, and that's okay. Okay, so if this is 30 and this is 60. Okay, so let's say that this piece here, let's say this was 15 units. And then across from this is double that, so that's 30. And then across from this is going to be 15 root 3. And now what I want to do next is kind of start looking at some ratios here. So with respect to this 30-degree angle right here, let's look at the ratio of the side that is opposite that to the side that is the hypotenuse. So let's take a look at that ratio in all 3 of these triangles. So in my first triangle, my opposite with respect to this 30 is this 4. And my hypotenuse is 8. In this triangle right here, with respect to this 30, my opposite is this 5. And my hypotenuse is 10. With respect to this 30, my opposite is 15, and my hypotenuse is 30. Notice that every single time the ratio of my opposite to my hypotenuse is in simplified form. 4 to 8 would simplify down to 1/2. Okay, and that's every single time, no matter how big or small I draw my triangle. And that's of course happening because these are similar triangles. There's a certain ratio with the sides that has to happen every single time. So this triangle is similar to this triangle, is similar to this one. And it's not possible to break this ratio. And actually, this is kind of cool. This ratio is programmed into your calculator. When you're looking at the ratio of the opposite side to the hypotenuse, the special name for that is sine. Okay, and if this is your reference angle, you would say the sine of 30 degrees. And I want you to take a moment and just type that in your calculator. Type in the sine of 30 degrees and make sure your calculator is in degree mode and not radian mode. Otherwise, you're not going to get this to work. But the sine of 30 degrees, your calculator should spit out 0.5 or 1/2. That's because that's my ratio of my opposite to my hypotenuse for any 30, 60, 90 triangle. Now let's take a look at this example. Let's do this 45, 45, 90 real quick. You pick a different color here. So using my relationship, let's say that across from this 45, let's say this is 7 units, and across from this 45, these are the same. This is 7, and I know that this side right here would be 7 root 2. Okay, now this time, instead of looking at the sine of 30 degrees, let's take a look at the sine of 45. Okay, so in this triangle, if I look at my opposite, so that's 7 over my hypotenuse, that's 7 root 2. And you can simplify this a little bit. These 7s would cancel out. So the ratio comes up to be 1 over the square root of 2. And I don't want that square root in the bottom there. So let's rationalize this real quick. And I get the square root of 2 over 2. Now let's find out what this would be in decimal form. What is the square root of 2 divided by 2? So let me go over to my calculator here, and we're going to type in the square root of 2, and we're going to divide that. Okay. All right, I had a mistake with my calculator there. I fixed it up. So I'm going to type in the square root of 2 divided by 2. And notice my decimal is 0.707. So let's copy that over here. Square root of 2 is about, now this was rounded, 0.707. And if type in sine of 45 into your calculator, and you should get the same exact number, because that is the ratio of the opposite to the hypotenuse in your right triangle here. So the ratio of this side to this side is 0.707. And this idea with ratios, there's not just the sine, but just to give you a quick introduction here, there's also the cosine of an angle. So here we'll just put cosine, we'll call the angle angle A. The cosine is equal to the adjacent side over the hypotenuse. And there's also a tangent. So let's say the tangent of angle A. And the tangent is the ratio of your opposite side over your adjacent side. So what I'd like you to try to do is take your triangle and pick an angle, like say the 60-degree angle here, and take a look at, exploring the cosine and tangent and see if you can get the math to work out when you type in the angle into your calculator and you compare the ratio in the triangle that you've actually drawn. So for example, with the cosine of 60, for example, I can type that into my calculator, cosine of 60, get what that is in decimal form, and then take a look at using this right triangle. So my cosine of 60 would be my adjacent, which would be 5, over my hypotenuse, which would be 10. So for cosine of 60, I should be getting 5 over 10, or 0.5. See if you can get that to work with using different angles, 30s, 60s, and 45s, and using the different trig ratios of sine and cosine and tangent.